Hello everyone, this is Noah again with 2.2 for Math 302. Forgot to put that. Okay, so this time what we learned about was the elementary row operations. Okay, so these are things that we're going to be using to pretty much solve a puzzle when it comes to a system of equations. Number one is what we can do with the lines on a matrix is that we can add a multiple of one row to another. And I'll show you an example of that in just a sec. We can multiply any row by a non-zero scalar. And that's important too. That can make your life a lot easier. Don't forget that one. We can swap any two rows, and I'll show you an example of that in just a second. Notice any of these rules make an equal matrix. So these are real math things that they look like they change the equation totally, but it is an equal system no matter what you do to it. Okay, as long as you follow these rules. All right? So these rules, the purpose of these rules is to get to a different form, either the triangular form or the row echelon form. What the row echelon form is that the first non-zero entry is in each row is to the left of the non-zero entries of the rows below. And I'll show you what that looks like. You can also go to a reduced row echelon form. This is all pivots are 1 and all columns with pivots have zeros in the other positions. Okay? So here we have just row echelon form, and we have a pivot here with zeros in the rest. So zeros all below it, so that means that everything else is every other non-zero term is to the right. We have another pivot here, which means that there's zeros below it, and every other non-zero term is to the right. And then one last pivot here. Every other non-zero term is to the right. Okay. Now, the reduced form of this looks like this, where notice in each of the rows where there's a pivot. Oh, that's zero supposed to be over there. Yikes. Bad handwriting there. There's a pivot here, pivot here, pivot here. 1, 1, 1, 1. All pivots are 1. And there's zeros in all of here. Okay? So this is ideal for solving for a system of equations where you have less equations than you do variables. Because then, and I'll show you that on the back of this paper, it makes it easier to solve. It's like solving itself. Really, to get from the matrix you have to this matrix to this matrix just takes practice of using those three things. That's all they are. Okay. All right. So, what's the point? What's the point of using matrices and getting it to row echelon form and things like that? Well, it's to solve systems. Okay. And previously we've been learning about planes and lines and vectors and things. So we want to learn, these are all going to intersect, or are they going to intersect? So we want to solve them. And so when you have, 10 planes and, you want to know, are they going to, you want to find the solution. Where do they intersect with each other? If they do. And so it comes in handy when you're using tons of equations. Also note that sometimes you want to be able to get all solutions as a number, but you can get lines as solutions as well. Not numbers, but solutions. Bad handwriting there. Meaning if I have a plane here and a plane crossing with it, then I have two planes, and planes have three variables. So I have these two equations here, but only three variables. But really, if I've got this plane stretching out of this paper or into the paper, whichever, and this plane stretching out or into the paper, that means that they're colliding infinitely amount of times in that third dimension. So that's why you would get an answer in an equation, because really they're not intersecting at a point, they're intersecting at a line. Okay? So, for example, we have these two equations. usually you'd look at this and you would say, well, let me put in t for z just so it looks familiar, like a parametric equation, and let me substitute. And then you go through all this forever substituting and craziness, and it takes forever, and you end up getting this answer, which is correct. Or you can go the matrix route. So there's Gaussian elimination, where it's just row echelon form and then you solve. Or there's Gaussian Judam, I have no idea on how to pronounce or spell these names, elimination, where it's reduced row echelon form. So notice when I took a matrix that we would have, an augmented matrix that we would have written with just the coefficients of the variables there, if I changed it to row echelon form and then from row echelon form to reduced row echelon form, notice that the numbers I get in this matrix, which is reduced echelon form, are the same numbers that we got for the answers in substitution. So really, it's helpful when you have 10 equations and 15 unknowns or something ridiculous like that, just putting in reduced row echelon form saves you a ton of time on substitution. So that's good to know there, because now I can just read it off. All right, some things to remember. There are many ways to write a solution. There's vector forms, parametric forms, point forms, matrix form, all things like that. Columns without a pivot in row echelon form are free variables, okay? Meaning they are just the equation. So like up here, z was a free variable, meaning it's there was no exact value for it. It is free to be whatever it wants to be. It's a very liberal z. Okay, so let's start with this. Let's do this example of using the elementary row operations and solve this system. Okay, so we have a 4x4, a 4x5 here. Well, these are the answers. So here's this augmented 4x4 matrix, and these are the answers on the side. And so I'm going to change it. So first thing I did was I swapped the rows from the original matrix so that I had a 1 on top. I find it easier to have a 1 on top. That way I can multiply this by whatever I need to and add it to the others. So a -2, a -2, and a negative. So I did so and got these numbers. Now I'm good on this row. It's got zeros below it. So now I need to get this one, this pivot, and get zeros below that one. So multiply this by whatever I need to, and then add and add. And so I get this. And then same thing. Here's my pivot. Multiply what I need to, and then add. And I get this. Notice now I have it in triangular form, which means fastest way to solve this is back substitution. So after a lot of substitution, I get these answers for my 4 variables. So that was just a quick example, but it's really just a puzzle. Try some little tips. Try and start with 1s. It was really nice that after I put a 1, I switched the 2 equations that I just kind of had always a 1 to work with. And be aware that you can also multiply by scalars. So say I didn't have a 1 here at first. Maybe I just need to multiply by a 1/2, and then I would have a 1. And so think about that, and that can make your life easier as well. Okay, hopefully you enjoyed. Post any questions. Thanks.